Hello, future McNair scholars. My name is Kayla Siddell, and I am a master's student in the School of Information Science at the University of Tennessee. I am a previous McNair scholar from ETSU, years 2009 and 2010. I would first like to congratulate you for being chosen for such a fantastic program, but also for having the incentive to pursue it. The fact that you've chosen to participate in the McNair program is a sign that you're all interested in pursuing a graduate degree and that you have some interest in research and data. Well, I'm here today to introduce you to an exciting but little known field called data curation. Now, I know what your first question is. What is data curation? Well, one definition is the active and ongoing management of research data through its life cycle of interest and usefulness to scholarship, science, and education. Now, I know this may sound a bit vague, but let's take a look at some of the key words here. Active and ongoing management. Now, this is very important because when we speak of management in regards to data curation, we don't mean collecting data, putting it in a database, using it for your paper or poster presentation, and then simply storing it on a flash drive and saving it in a drawer somewhere. No, we're referring to actively updating, cleaning, verifying, and preserving data for your use as well as others. Also, here you will see that we refer to a life cycle. Now this is important because data has a special life cycle that it should go through. But many researchers are either unaware or choose to overlook this process. Now, lastly, this mentions usefulness. This is also a goal of data curation, getting the most usefulness out of data. Continue by looking at some of the functions and tasks associated with data curation. One function is to enable discovery and retrieval of data. This is done through metadata, which we will discuss more later. Also, we aim to maintain data quality and add value to it over time. We want to provide for the reuse over time by archiving and through means of preserving. Now, what are the tasks that are associated? Well, we must appraise and select data. We will have to find a way to represent this data. We have to authenticate to ensure that of its quality. We also want data integrity, so that we would want to know if the data that we're looking at is the data that we think we're looking at. Is this the same data that we looked at last week? Has something been changed? So that's something that we also have to think about. Also, we like to maintain links between data. Perhaps two data sets are related. We'd like some way to let the user know that these are related and that they should be linked together. Also, our concern is format conversion. How can we make sure that the version that we have will be compatible with the version that you have? Earlier, if you remember, I mentioned the data lifecycle. Well, as you can see here, Data 1, which is an acronym for Data Observation Network for Earth, is a project supported by the NSF under the DataNet program, and they provide scientific data archiving for ecological and environmental data. Now, this is a great organization in the field of data curation because they do a lot of archiving, they do a lot of data curating, and one of their contributions is this great data life cycle. Now, you see that data is a living thing. It should not be stagnant. It is a process. So you can see that we have plan, collect, assure, describe, preserve, discover, integrate, and analyze. Now, this life cycle isn't always exact. Some people may start at different places. Some may begin their job at the discover, or some people may only be associated with the plan and ensure. The important thing is that the data does go through the cycle. So let's look at some of the elements of this life cycle and understand it better. Okay, now we're going to take a look at the data life cycle. The first step is to plan. A description of the data that will be compiled and how the data will be managed and made accessible through its lifetime. So this is done through a data management plan, which is something that you would sit down with your team before you even start collecting your data and decide what data you're collecting, how it's going to be described, the units it's going to be described in, the file type that you're going to use, XML, comma separated, how much file space is it going to take up, where are you going to send it to be archived, how is that going to be accessible to others, when are you going to make that accessible. So all these things are things that you would want to put into your data management plan. Once you've completed your data management plan, you would then go and collect your data using whichever instrument, sensors, or hand, by man, by in the field, however you collect your data. Then you want to assure your data through different checks and inspections. So data quality is very important and should always be a priority. Once you've collected and assured your data, then you want to describe it. And when you describe your data, you need to be sure that you're using the proper metadata standards for the purpose of your data and where you're going to be sending your data. Next step is to preserve your data. So data is to be submitted to an appropriate long-term archive. So this could be a data center, this could be a repository like +ONE, which is an open access science repository. So you want to decide where you're going to send your data to be kept for long term. And this is not just for your own use, but for other scientists and researchers' use. Also, you want to discover or locate other data that could be relevant to yours using metadata. You could look for other relevant data sets or other relevant projects and link the two together so that those who are searching for the data can find them together. Also, you want to integrate, so it's good if you can find a way to take different sources and put them together into one data set and analyze them in some systematic way. Also, it's important to analyze your data, and that can be done through many different ways. Most people use different tools or programming. So, we've come to the question, why is all this necessary? Well, for several reasons. One is preservation. Data centers and repositories are set up specifically to maintain and preserve data. And not only that, but they also contribute to data sharing, which is advocated through open access. Open access is the idea that it's better to share our data with one another than to sell it only to those who have the funds to receive it. If we're sharing with everyone, we're not only helping ourselves, but we're helping our field, and we're helping each other. And I think that that's really what we need to focus on, not about making profits, but about making contributions to making a difference. So if we can preserve our data so that we can look back at it and still maintain it and also share it, we are all going to contribute to the field. And there's been tenure concerns. If I publish to an open access journal rather than a for-profit journal, am I less prestigious? Well, no, I don't believe so. And the more of us who advocate for open access, the better it's going to be for everyone. So we all have to get on the bandwagon and say, hey, preservation, open access, and let's not discriminate against open access. Good science is good science. Now, we finally come to metadata. Now, we've discussed it quite a bit. What is metadata? Metadata is data that provides descriptive information such as content, context, quality, structure, and accessibility about a data product and enables others to search for and use the data product. Now, all that to say that the reason that metadata is important is because when we have a bunch of information, we need an efficient and standard way of organizing it. We do this through metadata. Metadata is information about the data. So, I have an example right here from a website called datasite.org, which is a great site, and I recommend that you check it out. It's basically made around the idea of metadata and citations. So here's an example of the ORNL DAC best practice, which is an distributive active archive center that is also doing data curation for NASA data and other bioscience data. So this is an example of what metadata looks like. This is a XML format. You see the first line, you have the identifier, So next you have Creator, and it's created by the Environmental Science Division of Oak Ridge National Laboratory. You have Date, which is 2010. The Identifier, which is the DOI. The Publisher, which is ORNL DAC for Biogeochemical Dynamics. Also, you have the title, which is called Best Practices for Preparing Environmental Datasets to Share and Archive. You have Same As, which is the DOI, and it's closed out. So this is the information about the product. This is how you describe and how you would search for each of these: creator, date, title, identifier. They're each metadata pieces that you can use to find this exact paper. In conclusion, today I've tried to give you a quick overview of what data curation is, how it works, what it entails, and how we go about it. Now, you all are the future. You have an opportunity today to decide: would you like to be a part of the future? Would you like to be an information professional and contribute to the future knowledge of the world? If so, you will be faced with certain tasks. One is to inform others about the importance of data sharing. It is very important that we help researchers and universities understand how important it is to share data with others, how much help it could be to the world, to each other, how much easier, how much more efficient would research be if we could have open access to each other's information. Also, we are tasked to improve metadata awareness and training. It is mandatory that we help others understand what metadata is and how it's used so that they can be more equipped and better prepared for data curation. If those who are collecting the data and providing it understand the importance of metadata and how it works, then they can present the data to us and metadata to us in a more efficient way, and therefore we can be more efficient about archiving and preserving the data. So it is our job to educate them so that they can provide us with better products, so that we can provide the world with better products. Also, we are tasked to increase access to needed tools. All these things in data curation aren't magic. It takes work. It takes tools. Some take programs. There's many different tools that we use to produce these data products. It's very important that we all have access to them and we provide access to others, because if we can all use the same tools, it'll be easier and more efficient. This is what we need: ease and efficiency and standardization. Also, one of our final and most important tasks is to provide incentives and motivations for others to get involved in data curation. We want to get the word out that data curation, data preservation, and archiving is important. We are behind. We need to catch up. We need to help others understand why we want to preserve this data, what this data can mean for us in the future, how helping each other can be a better process than selling information to each other. So, if you think that this sounds like something that you're interested in, if you feel like you want to be an information professional, a data curator, then please look at your handout, check out some of the additional information that I've given you, and feel free to contact me, because I would love to tell you more about the exciting field of data curation. Have a good day.